What's up, it's Carter, and in this video we're going to be taking a look at oxygen sensors, heated oxygen sensors, as well as different fuel trims across different vehicles. The vehicles referenced in this video are a 2006 Toyota Corolla, a 2005 Pontiac Grand Prix, a 2017 Buick Encore, and a 2011 Chevy Equinox. Starting testing on the 2006 Corolla, as you can see we have a manufacturer-provided test. The sensor should be reading 1.8 to 3.4 ohms at 68 degrees Fahrenheit. As you can see from this video, the isolated sensor is reading about 2.9 ohms. After the vehicle has been warmed up, we re-isolate the sensor and you can see a reading of 4.9 ohms. Here I'm just demonstrating how testing with a voltmeter can be difficult, as the voltmeter is not able to recognize the switching signal and gives you an average voltage. Here you can better see the voltage readings on the scan tool. You can see how the voltage is constantly fluctuating on sensor 1 of the oxygen system. In this clip, I am demonstrating how the oxygen content in the exhaust changes with engine RPM and how the sensor reads that. Here I am showing how you can use different options on different scan tools to get the same test results. Starting testing on the Pontiac Grand Prix, we used the Snap-on scan tool to monitor both oxygen sensors. As you can see from the scan tool data, the voltage on the sensors is constantly alternating between high and low. I also did testing on a 2017 Buick Encore. This car is equipped with a wideband sensor, and I did my readings with a top-down scan tool. In this video, you can see the comparison between both heated oxygen sensors against engine runtime. Here we can see the difference between long and short-term fuel trims. As you can see from the data, if the vehicle is below a certain value or above a certain value for too long, the long-term fuel trim adjusts for that short-term fuel trim value. Here we are using the scan tool to display both heated oxygen sensors as well as long and short-term fuel trims. This is useful to be able to compare how the sensors affect fuel trim. Here we are individually testing the heated oxygen sensor. As you can see, it is giving us not only a number value for voltage, but also demonstrating this voltage change on a graph for us. Here we are running the same scan tool test, but on the downstream sensor. I finished off testing on the 2011 Chevy Equinox. I used the Equinox and created a lean condition using propane injected into the intake manifold. As you can see on the scan tool data for both sensors, once propane is added, there is a sharp drop-off in the voltage and a lean condition is created. When we add propane to the system, you can see a sharp drop-off depicting a lean condition.